Before going to the next section, serial communication, let me discuss what are the things we have covered till now. We have covered what is microcontroller, what is the family, what are the families we have it, what are the packages we have it. I have introduced what is Arduino. We came across the Arduino ID. What are the things available on Arduino ID? Then we have saw what is datasheet, how it looks, what are the things we have to take care of it when we are doing any coding, what are the things we have to look in datasheet when you are coding it. We have also seen the schematics of both board, nano and uno. Then we have worked on GPIOs, digital pins, with coding. What is the structure of coding? What are the things involved in coding? We have seen all those things. Now, before going to the next section, let me introduce very basic, very normal used serial communication thing, that is UART. Okay, fine. What is UART? What is the full form of UART? UART is like Universal Asynchronous Receiver Transmitter. Why it is called as asynchronous? Why it is not synchronous? These questions will raise. Synchronous is very easily, if I say, it depends on the clock cycle, right? So it is this UART. In this UART, if you want to send the data, we are not at all synchronizing with any clock signals here. We need two bits, that is a start bit and a stop bit. So when we get a start bit, that means that the data transmission has been started. Once we get the stop bit, it means that the data is ended off. Even in other side, in the receiving side also, the same thing happens. This is what I am trying to say here. Instead of clock cycle, the transmitting UART adds start and stop bit to the data packet being transferred. These bits being defined beginning and end of the data packet, so the receiving UART knows when the starting reading of the bit, right? So since we are working with microcontroller, we have to know the digital voltage levels. In our TTL, that is transistor logic, in which our controllers or microprocessors works, this is TTL. In this TTL, high means 5 volts, we all know it, low is 0 volts. But in UART, there is a protocol or there is a logic called RS232. So in this, high is minus 12 volts and low is plus 12 volts. If we want to use this, when we are using this from microcontroller to the PC, our PC works with RS232 logic. So if you want to communicate with the PC and the controller, we have to have a level shifters. So in previous video, I have been explained to you. We have in nano board, we have a RS232 to TTL converter, right? So moving forward, when we are connecting from device 1 to device 2, the device 1's TX should be connected to RX and device 1's RX should be connected to device 2 TX. It should be a cross connection, right? So you can't connect TX to TX. You can't you can't hear if you can't hear and speak both with your mouth, right? Same thing. So the frame format of the UART looks something like this. The data part will be like from D0 to D7, D0 to D8. That is either it is the 5-bit data or it can be a 8-bit data depending on our requirement and the controller. So it starts from S, that is start bit, D0 to D7, parity and stop. What is parity? Parity defines how many number of ones are present in data. So this is one of the important thing to be understood, baud rate. So baud rate defines how many bits are getting transferred per second, that is BPS. So you can see there the waveform. So it says that both the transmitter and receiver has to agree upon a common frequency. You can't send like we have several baud rates, like it starts from 4,200 to it can go up to 19 lakh to 20,000. So if I'm speaking in 4,200 baud rate and if you're receiving in 9600, you can't understand. For example, now if I'm speaking in English and you don't understand English, you understand only Hindi or other language, then the data transmission is lost, right? Same thing. Even you should know English, I should know English, or any you should know that local language, even I should know that local language. So we use these kind of connectors when we are working with RS-232 serial communication. One is DB9 connector and another one is DB25 connector. DB25 connector are basically, you can see it in printers. So both DB9 and DB25 will be available in male connector and female connector. Right. So in this, why this is called a serial communication? Why not parallel communication? Because here the every bit is sent in serial format, like 0, 1, 0, 1, like that. Right. This we have seen it. So if you, as I said, it has to be connected with the laptop with our cable. So I have introduced the serial monitor, how it looks, which port you are connecting, all those parts. In our Arduino, why we are using the serial communication? In Arduino board, we have, as I said, that we have two LEDs to show you whether the data is transmitting or receiving it. So those two LEDs are TX and RX, which has been placed on our board. Right. So one thing is we use it for compiling. Second thing, uploading the code. While uploading the code, both the receiver and transmitter light blinks because it has to send. There is a in bootloader. There will be a code that to send acknowledgement once the code has been uploaded. So this is how actually the serial monitor looks. I mean, where you can open the serial monitor and how it looks. I'll be taking care more about in my demo video. Right. There are some basic and important serial commands which we'll be using in our code. So serial dot begin, baud rate, that is 9600. Either we can give directly serial.begin. Default it will take 9600, or if you are using some other serial port communicator devices like GSM, GPS, we have to mention which baud rate we are working on. Serial print is to give the output. Serial print ln, it will be like next line. Same print will be a next line. So example, you have to provide the value, what value you are sending, whether it is a value, whether it is a string, what exactly. Serial read is to read the data from the serial port. Serial available is to check whether any data is available on my serial buffer. Again, the serial write, serial print is for a single byte. Serial write is for the array of characters. Parse init, we have, if you want to split the data, the parsing, right? So in our example code, here I am reading the port. In that port, there are 3 pins. One pin I will be connecting to my A0, another 2 pins will be connected to VCC and ground. So whenever I change the knob, when I rotate my knob, the value of the value of the analog read is thrown on serial monitor. I'll be taking more examples, reading the sensor data and other part, how we can map it, how we can use it for your code. Those things I'll be explaining it. So thanks for today. Let us see the demo.